Explanation: a line that is inclined to both principal planes, the horizontal plane HP and the vertical plane VP, is a line that does not run parallel to either of those planes. Imagine a flagpole that is not standing straight up, parallel to VP, nor lying flat on the ground, parallel to HP, but is slanted in a direction that touches both the ground and the wall. Classification: 1. Line lying in a principal plane dash its inclination to that plane is 0 degrees. 2. Line parallel to one principal plane but inclined to the other dash, for example, a roof beam that runs parallel to HP but rises upward, so it is inclined to VP. 3. Line inclined to both planes dash the general case we study. It meets HP and VP at two different angles. 4. Line intersecting both planes at a single point dash a special case, where the line passes through the origin of the orthographic system. Understanding the class tells us which projection techniques are needed. From this explanation, you just need to break them into segments, and for each segment return phonetic reading style of the segment. To describe how a line lands, we measure 3 inclination angles. Alpha, angle between the line and the horizontal plane. HP, think of looking at the line from the side. Alpha tells how steep the line climbs from the ground. Beta, angle between the line and the vertical plane. VP, imagine standing in front of a wall. Beta shows how far the line deviates from being vertical. Gamma, angle between the line and the profile plane PP, which is perpendicular to both HP and VP. These angles obey the direction cosine relation. Cosine squared alpha plus cosine squared beta plus cosine squared gamma equals 1. You can find alpha and beta by measuring the projected length of the line on HP and VP and using trigonometry. Cosine alpha equals true length divided by projection on HP. Similarly for beta. In practice, the angles are often given in the problem statement or obtained from a known slope of the line. Third angle projection uses an auxiliary plane that is perpendicular to the line we want to measure. Step 1. Choose an auxiliary plane, a P, that contains the line and is orthogonal to it. This AP becomes the new true plane because the line lies flat on it, so its length on a P equals the real length. Step 2. Rotate the object, or imagine rotating the view so that a P aligns with the drawing sheet. In a drawing, you first draw the line's projection on HP and VP, then draw a third view, the auxiliary view, where the line appears at its true length. Step 3. Measure the line directly on the auxiliary view. That measurement is the true length L. Analogy: think of a crooked stick lying on a table. If you lift the stick and place it on a separate flat board, the auxiliary plane that is exactly under the stick, the board shows the stick's true length without any foreshortening. In third angle projection, the board is imagined to be behind the original drawing sheet, so the auxiliary view appears to the right of the main views. In first angle projection, the auxiliary plane is still chosen perpendicular to the line, but the view arrangement is opposite to third angle. The object is placed in the first quadrant, and the auxiliary plane is imagined to be in front of the projection plane. When you project the line onto the auxiliary plane, the resulting auxiliary view is drawn on the left side of the principal views, HPVPP. The construction steps are identical to the third angle method. Pick a plane orthogonal to the line, rotate the object, draw the true length. Only the placement of the auxiliary view on the sheet changes. Real-world picture: imagine looking at a building model through a glass pane, the auxiliary plane. In first angle, you view the model through the pane before it reaches the drawing board, so the pane's picture appears on the left side of your notebook. Explanation: once the true length is known, you can place the line on the 3 principal planes using the auxiliary view as a reference. Projection on HP: drop a vertical line from the ends of the true line onto HP. The segment between the foot points is the HP projection. Projection on VP: drop a horizontal line from the ends onto VP. That segment is the VP projection. Projection on PP profile: drop a line perpendicular to PP from the ends, you get the profile view. Using the auxiliary view as a master ensures that the 3 projections are consistent with the same line orientation. Example: a pipe that goes from the floor upward and sideways. After drawing its true length on an auxiliary view, you draw its shadow on the floor plan HP and on the elevation VP. The three shadows together reconstruct the pipe's spatial path. Explanation: let L be the true length of the line. Let L sub H, L sub V, and L sub P be the measured projected lengths on HP, VP, and PP respectively. The inclination angles are alpha, beta, and gamma. By definition of cosine for the angle between a line and a plane: cosine alpha equals L sub H over L, cosine beta equals L sub V over L, cosine gamma equals L sub P over L. Rearranging gives three equivalent expressions for the true length: L equals L sub H over cosine alpha equals L sub V over cosine beta equals L sub P over cosine gamma. If only two projections are known, you can still compute L using the corresponding angle, and the third projection can be obtained from the direction cosine relation. Numerical example: suppose L sub H equals 40 millimeters and alpha equals 30 degrees. Then L equals 40 divided by cosine 30 degrees equals 40 divided by 0.866 equals 46.2 millimeters. The same L must satisfy L sub V equals L cosine beta. If the measured L sub V equals 35 millimeters, then beta equals arccosine of 35 over 46.2, approximately 43 degrees. This consistency check is useful in exams. Sample exam problem: third angle. Number 1. A line has projections: a B equals 30 millimeters on horizontal plane and CD equals 24 millimeters on vertical plane. The angle with horizontal plane is alpha equals 45 degrees. Find the true length and draw the auxiliary view. Compute L. L equals 30 divided by cosine 45 degrees equals 30 divided by 0.7071 equals 42.4 millimeters. Verify with vertical plane. Cosine beta equals 24 divided by 42.4 equals 0.566. Therefore, beta is approximately 55 degrees. Draw horizontal plane and vertical plane views as given. Construct an auxiliary plane perpendicular to the line. Rotate the line until it lies on a new plane. The line now appears as a 42.4 millimeter segment. Place this auxiliary view to the right of the principal view's third angle rule. Sample exam problem: first angle. Number 1. The same data as above, but the drawing follows the first angle convention. Steps 1 through 3 are identical. The true length is still 42.4 millimeters. The auxiliary view is drawn to the left of horizontal plane and vertical plane views. Projection of the auxiliary line back onto horizontal plane and vertical plane yields the original 30 millimeter and 24 millimeter segments, confirming correctness. Step-by-step checklist for both systems. A. Identify given projected lengths and any inclination angles. B. Use L equals L divided by cosine theta to compute true length. C. Choose an auxiliary plane orthogonal to the line. D. Draw the auxiliary view, right side for third angle, left side for first angle. E. From the auxiliary view, drop perpendiculars to obtain the line's shadows on horizontal plane, vertical plane, and profile plane. F. Label all angles and dimensions for full credit. These systematic steps help students solve any line inclined to both planes problem efficiently.